Hello, we have done a final year project on real-time object detection for visually impaired people. One of my team members is Aritro Mukherjee, who helped me to build the project successfully, and thanks to our mentor Professor Nilanjana Datta Roy for guiding us. Now, the blindness may be caused due to temporary or permanent injury to eye or optic nerve, which leads to blindness. But the blind people uses braille to learn by themselves, and also many electronic devices are developed for blind people. But we have implemented a simple system which helps blind to move independently. Next we come to our objective, where we will develop a system which detects obstacles and position of it and instructs him in order to avoid collision. As blind person can't see, so instructions given by the system should be of audio so that blind person can understand the instruction. For our project, we need Python 3.5 of 64-bit and also TensorFlow. But here, point to be noted that the TensorFlow works only on 64-bit. So we have to download the Python of 64-bit, not the 32-bit version. And also, here we need a YOLO model for object detection. Now, so go on the steps of our project, where we will do our video capturing through laptop webcam. Then we will implement our TensorFlow models. Then we will load some label maps, and then we'll train our video with our pre-trained models that we will use as COCO models, COCO-api models, and then we will do some bounding boxes of the object, where we will show some corresponding levels and score. Here, the score is the probability or percentage of accuracy that the system can understand that the object is. And then lastly, we will come to the object detection part, where we will detect some chair, mobile person, etc. Now come to our installation part. We need to install TensorFlow, Protobuf 3.0.0, Pilo, Matplotlib, Python, and COCO-api. How to download all those libraries? Here we have to open the command prompt and then run as administrator. Then let's say we will install TensorFlow model. Then we will write in the command prompt that pip install TensorFlow, and then we will enter. And then as I have TensorFlow model installed in my computer, so it's telling us that requirement is already satisfied. But otherwise it will download the models, and like this we will download other libraries also. Then comes with the TensorFlow Object Detection API. The TensorFlow Object Detection API is an open source framework built on top of TensorFlow that makes it easy to construct, train and deploy object detection models. Now comes with the COCO-api models. COCO-api is the trained model set for the pre-trained level data sets for object detection. The COCO model is listed in the figure, which are listed here, having fields of speed and COCO-map. We have to keep in mind that more the speed, less powerful, and also the less the speed and more powerful the COCO model is, because if the model contains more pre-trained level datasets, it takes obviously more time to download those models, and also detect every images with larger amount of data sets in that model. In this slide, we can see the performance graph of YOLO to other detectors like ReturnNet 50 and ReturnNet 101. Here it shows that YOLO is far better than all those detectors having high COCO-api value. And also there is a list of performance on COCO dataset. And here we can see that YOLO has very higher MPS values, whereas in ReturnNet 50 or ReturnNet 101 there is having 1411 MPS. So obviously we can conclude that the performance of YOLO on those COCO dataset, obviously YOLO is far better than other detectors. Now comes the working of YOLO model. Here we are taking video and giving the video feed to the model. Here it changes the video into frames and each frame is divided into grids. Let's say it has an image of dog and bicycle in the picture given here. Then it repurposes, classifies or localizes to perform detection. Then apply the model to an image at multiple locations and scales, and then high scoring regions of the image are considered detections. This network divides the image into regions and predicts bounding boxes and probabilities for each region. These bounding boxes are weighted by the predicted probabilities. It loops the whole image at test time, so its prediction are informed by global context in image. It makes predictions with single network evaluations, but in RCNN, which requires thousands of network evaluation for single image. In RCNN, each grid of the image is compared with the pre-trained models. So YOLO is much faster than RCNN. Then the flowchart of our project, that is, we have to first capture the video, then the video is converted to frames and the frames are sent to the models for object detection. Here we have used a YOLO model. Then we have to save the tensors, that is type of object and its accuracy. Then we will create a grid in the frame. From the tensor data that we saved, we can get the hierarchy detected. Using the hierarchy, we can find the object closest to the camera. Then if the left side of the grid is free and the bounding box of the object is occupying rest of the grids, then the user will be instructed to move left. And similarly, if the right side of the grid is free and the bounding box of the object is occupying rest of the grids, then the user will be instructed to move right. And similarly, if the bounding box of the object is occupying whole of the grids, then it will show stop. Demonstrating our output of the program, here there is a chair and so it's telling move left. Here as the object is on the left side, so it's telling move right. Then obviously move left. Yeah. Then obviously move left because the object is on the right side. Thank you for watching our video.